Hey Pharma Digitalized subscribers! Before I get into my story, let me first introduce the backstage crew who made this possible. This tale was scientifically scripted by Professor Dr. A. Jerad Suresh, Principal of Sri Ramachandra Faculty of Pharmacy, Sri Ramachandra Institute of Higher Education and Research, DU, Porur, Chennai. And then it was digitalized by Ms. Reshma Devi Senthilnathan, Research Scholar, Department of Pharmacognosy, SRFOP, Sriyar, DU, Porur, Chennai. Hello there. I am a red blood cell, born in the bone marrow factory. My job is to carry oxygen faithfully, but today I must share a story of a drug that is both a miracle and my greatest challenge. Back in 1947, scientists discovered chloramphenicol, the first broad-spectrum antibiotic to be produced synthetically. Isolated from Streptomyces venezuelae, it became famous for saving lives from typhoid fever, meningitis, and more. Let's step into the chemist's laboratory. See how, through a carefully sequenced set of reactions, bromination, amination, formylation, acetylation, reduction, and chiral resolution, chloramphenicol emerges. Each atom, each bond, created precisely for the battle against bacteria. Chloramphenicol now stands complete, every bond crafted for a purpose. But as this chemical warrior emerges from the laboratory, it enters a world gripped by fear. A world still under the iron rule of a microscopic tyrant, Salmonella typhi.
I once ruled without fear. Typhoid fever was my kingdom. My cousins, paratyphi A, B, C, caused paratyphoid fevers. Typhimurium and enteritis spread food poisoning. But I, typhi, was untouchable until chloramphenicol arrived.
In the midst of this invisible war, humanity stands at a crossroads. Two champions prepare. One, penicillin, with its iconic ring forged from valine and cysteine, designed to shatter bacterial walls. The other, chloramphenicol, streamlined and precise, built upon a nitrobenzene core and dichloroacetic backbone, set to strike at the protein-making heart of the cell. Chlorampphenicol's power lies in its structure. Paranitro group on the benzene ring, essential for activity. Dichloroacetamide side chain, enhances antibacterial potency. Primary alcohol group, critical for ribosome binding. Correct stereochemistry, required for maximum effect. Every atom has a purpose. Change any part and the antibiotic loses strength. And here's how it works. Chloramphenicol binds to the 50S subunit of the bacterial ribosome. It blocks the enzyme peptidyl transferase, the very catalyst that links amino acids together. Without peptide bond formation, bacterial proteins cannot be made. No proteins, no survival. It is a direct and powerful strike on the enemy's machinery. In battle, I watch chloramphenicol slip into Salmonella's realm and bind its 50S ribosome. Protein synthesis halts. The mighty micro grows weaker, its range shattered in my flowing world. But even as victory appears certain, a new struggle unfolds deep inside the body.
As a bone marrow, my turn comes, hidden in the bones. Chloramphenicol's power quiets my workshop. I can no longer send red cells, white cells, or platelets to protect and heal. This silence is aplastic anemia. For some, this is the ending no one expects.
And in newborns, the danger from chloramphenicol toxicity arises because their immature livers lack the enzyme uridine diphosphate glucuronidyltransferase, which is essential to metabolize and clear the drug. As a result, chloramphenicol accumulates to toxic levels, causing symptoms collectively known as gray baby syndrome, characterized by grayish skin, vomiting, hypothermia, and cardiovascular collapse. Outside, the victors and vanquished both carry scars. Salmonella sits dethroned and chained, its reign broken but the price of conquest heavy. So ends this tale, where medicine is at once savior and threat. Only with wisdom and vigilance do we harness chloramphenicol's life-saving promise, never forgetting the double edge of its power. From bone marrow to bites, my story is now digitally breathable. Subscribe for more. Thanks for watching.